Assalamu alaikum students. We continue review exercise 2 with the question number 2 in which we are required to identify true and false out of the 9 these given statements. So let's begin with the first statement, that is division is not an associative operation. For this we have to recall what is associative operation. An associative operation is for all A, B, C belongs to R. We have three variables. Any three variables belongs to R. A is divided by B divided by C equal to A divided by B divided by C. So let's check with an example whether it is, the equality does exist or not. So we take an example. Let's A is equal to 2, B is equal to 4 and C is equal to 8. We choose even numbers for ease. Right hand side we write as 2 divided by 4 in the bracket divided by 8. Let's solve these. 2. According to BDMS rule, we solve the bracket first. 4 divided by 8, we use calculator to simplify it. So we have 1 over 2. And when we do this one, we take its reciprocal, so that is equal to 4. That is the solution of left hand side. We take the right hand side. 2 divided by 4 is equal to 1 over 2. And that divided by 8. When we take its reciprocal, what we get? 1 over 8. So we have 1 over 16. And what we observe that left hand side had the answer 4, whereas right hand side had the answer 1 over 16. 4 will never be equal to 1 over 16. Hence, it means that division is not an associative operation because there is no association can be generated. Left hand side is not equal to right hand side by the example. So hence, that first statement is true. Division is not an associative operation. Let's move to the second point. Every whole number is a natural number. We write set of whole number to check 0, 1, 2, 3 and so on, and the set of natural number that consists of 1, 2, 3 and so on. And the statement is every whole number is a natural number. But what we see that the 0 is such a number which does not exist in the set of natural number. Hence, this statement is false. We move to the third statement. Multiplicative inverse of 0.02 is 50. So first of all, we have to find the value of 0.02. That is equal to, we remove the decimal, 2 over 100, 2 ones are and 2 50s are, and we get 1 over 50. As we know that the reciprocal of 1 over 50 is 50. Reciprocal of 1 over 50 is 50. And we know the simple concept, the multiplicative inverse are those numbers, their product is equal to 1. So when 50 is multiplied to 1 over 50, the product is equal to 1. Hence, the multiplicative inverse of 1 over 50 is 50. That is, the multiplicative inverse of 0.02 is 50. The statement is true. Now we check pi is a rational number. If we use a calculator, the value of pi is 3.1415926536. What we observe, the decimal part is non-terminating, non-recurring, and we know that the non-terminating, non-recurring decimal fractions are irrational numbers. So we check the statement pi is a rational number, that is false. Point number 5. Every integer is a rational number. As we learned already that integers are subset of rational number mean rational numbers are those which can be written in the form of a fraction, and every integers like a set of integers consist of -3, -2, -1, 0, 1, 2 and so on. And we know that these numbers can be written in the form of a fraction, -3 over 1, -2 over 1, -1 over 1, 0 over 1, 1 over 1 and so on. So these numbers can be written, mean we use 1 as a denominator for these. So every integer is a rational number. Every integer is a rational number. The statement is true. So let's move to the point number 6. Subtraction is a commutative operation. So for this sake, we first understand what is commutative operation for subtraction. For all A, B belongs to R, A minus B will be equal to B minus A. But we check with this an example. We take the value of A, let's suppose 2, and value B is 3. So 2 minus 3, and that is equal to -1. The value of B is 3 and value of A is 2. So 3 minus 2 is equal to 1. But what we get over here? -1 and 1 for the left hand and right hand side. -1 can never be equal to 1 according to the reflexive property. So that means A minus B is not equal to B minus A, and subtraction is not a commutative operation. Hence the statement is false. Let's move to the point number 7. Every real number is a rational number. Every real number is a rational number. We learn in the introduction of the complex numbers, that is, every rational number is a real number. Every rational number is a real number, but every real number is not a rational number. So hence what we come to know that every real number is not a rational number. So therefore that statement is false. In point number 8, decimal representation of a rational number is either terminating or recurring. We check with a few examples that 3 over 4, that is equal to 0.75, 1 over 2, that is equal to 0.5, and in comparison 1 over 3 is equal to 0.333 and so on, that is 0.3 bar, mean that is 3 is recurring, repeating. So 17 over 3, that is equal to 5.666 and so on, mean 5.6 bar. So 6 is the repeating factor. So hence what we know that these two categories of numbers in which the decimal fraction is terminating or recurring, these two categories are simply known as rational numbers denoted by Q. So it means the decimal representation of rational number is either terminating or recurring, because we know that pi is an irrational number and that is non-terminating, non-recurring. It means non-terminating and non-recurring decimal fractions are irrational numbers. So hence the statement is true. For point number 9, we recall the exercise 2.1 in which we learn how to solve such numbers. 1.8 bar is equal to 1 plus 8 over 9. As 1.8 bar is equal to 1 plus 0.8 bar. So let x is equal to 0.8 bar. We take the decimal part for the check of true or false statement. So 0.8 bar can be written as 0.8888 and so on, because 8 is the repeating factor because it is mentioned by the bar sign. We multiply both sides by 10. 0.8888 and so on. We get 8.888 and so on in the right hand side. We name this equation 1 and this as equation number 2. We subtract equation number 1 from 2. 10x minus x, and right hand side 8.888 and so on, minus 0.888 and so on. What we see, the decimal portion is cancelled due to the subtraction and we get 8. 10x minus x is equal to 9x, and x will be equal to 8 over 9. And hence we get the value of x is 8 over 9, and if we put the value 8 over 9 in place of 0.8, we get the same, this value equal to right hand side. Hence that statement is true. So that is all for the question number 2 for the identification of true and false statement. Thank you.